at another empirical formula determination through combustion. How to find the empirical formula of an organic compound through combustion of the compound. Let's take a look at this question that says 2.4 milligram of an organic acid gave 3.52 milligrams and 1.44 milligrams of CO2 and water, respectively, on combustion. Question now says, find, number 1, the empirical formula of the compound. Number 2, the molecular formula of the compound if the relative molecular mass is 60 grams. Let's bring out the values given to us. These are the masses given to us in the question. The mass of the organic compound, which we call the total mass of the sample that was burnt, is given to us in the question as 2.4 milligrams. And during the combustion, carbon dioxide and water were produced, and the mass of carbon dioxide produced is given as 3.52 milligrams, while the mass of water produced during the combustion is given as 1.44 milligrams. And we are asked to use this data to find the empirical formula of that compound that was burnt, and also find the molecular formula. Now, since it is an organic compound, we know that carbon will be present, hydrogen will be present. When we find the mass of carbon and the mass of hydrogen, we'll add the two together and check if it is up to the total mass of the compound. If it is up to the total mass, then oxygen will not be present. But if it is not up to the total mass, that is after adding our C and H together, if it is not up to the total mass given to us here, we will use oxygen to make it up. Now let's solve this problem. How do we find the mass of carbon? Please, I'm going to use shortcuts in this case. Anytime you are dealing with combustion question, combustion of an organic compound, and they give you mass of CO2 and give you mass of water produced, all you need is mass of carbon and mass of hydrogen. They will not give you the mass of carbon alone. They will not give you the mass of hydrogen alone. Rather, you will be given mass of CO2 and mass of H2O. So from CO2, you will find mass of C. From H2O, you will find mass of H. Because your empirical formula is C and H you are dealing with, not CO2 and water. No. From CO2, you find your C. From H2O, you find your H. Now, I'm going to give you a shortcut. I have given you the normal procedure in the previous video. In this one, we are going to use a shorter cut. Anytime you want to find the mass of carbon present in any quantity of CO2 given to you, just press this number, 0.273. This is constant. Whenever you want to find mass of carbon, you will use. So press 0.273 multiplied by mass of CO2 given to you. Mass of CO2 given in the question. If you do this, no matter the value of carbon dioxide produced, multiply that value of carbon dioxide given to you in the question with this value. How will you remember this number? This is the best way to remember this number. That value you use when you want to convert degrees centigrade to Kelvin, which is 273. Use that to remember the number. Now, the 273, just place 0 in front of it. It becomes 0.273. So this value is constant. Whenever you want to find the mass of carbon, you will use in the empirical formula. Now, if you press 0.273, multiply by the mass of CO2 given to you, whatever you get is the mass of carbon present. And that will give us 0.273 multiplied by mass of CO2 given to us in the question is 3.52. And that will give us 0.96 milligrams. Remember, the unit is in milligram. This is the mass of carbon present in that sample. How do you find the mass of H? I will still give you another shortcut. Anytime you want to find the mass of hydrogen present, you will find it from the mass of water given to you. Just press 0.111. This one is constant when you are finding H. Remember, if it is carbon you are finding, this is the constant you will use to multiply your CO2. But if you are finding mass of H, this is the constant you will use to multiply your water. Multiply with mass of water given in the question. Remember, you find carbon from CO2 given. You find hydrogen from water given. So this will give us 0.111 multiplied by mass of water given, which is 1.44. And that should give us 0.16 milligrams. This is the mass of hydrogen present in that compound. Now that we have mass of carbon, which we have gotten, we also have mass of hydrogen, which we have gotten. What next are we going to do? We are going to add our C and our H. If I add C plus H, what will I have? My C is 0.96 plus my H is, I've gotten my H, it is 0.16. If I add these two values together, I'm going to use my calculator. Okay, that will give us 1.12 milligrams. So the sum of carbon and hydrogen gives us 1.12 milligrams, which means it is not up to the total mass of the compound. This was the mass of the compound given to us. Our H and our C added together is 1.12. Now what are we going to do? We are going to use oxygen to make it up to the total mass. If you add your C and your H together and is equal to the total mass, it means that oxygen will not be present. But if you add them and it's not up to the total mass, you will use oxygen to make it up. Now what will be the mass of oxygen? Oxygen will be equal to the total mass, which is 2.4 minus the sum of C and H, which is 1.12. And if we do this subtraction, you are going to have 1.28 milligrams. This is the mass of oxygen present in the compound. Now with these masses, we can proceed to finding the empirical formula. Remember, if I add mass of carbon plus mass of hydrogen plus mass of oxygen, it will give me the total mass of the compound. So I'm free to solve. Of finding empirical formula, I have carbon present, I have hydrogen present, and I have oxygen present. Now, my mass of carbon is 0.96, mass of hydrogen is 0.16, and mass of oxygen is 1.28. You know the usual way? Divide by the atomic masses. This is 12, this is 1, and this is 16. What are you going to get? Here will give us 0.08, this is 0.16, and here is 0.08. You know the rule of empirical formula. The next thing to do is to divide by the smallest number, and the smallest value is 0.08. So I'll divide through by 0.08. This is 0.08. Divide by 0.08. Divide by 0.08. This by this is 1. This is 2. And this is 1. So the empirical formula of the compound, the empirical formula will give us C, 1 of it, H, 2 of it, and O, 1 of it. So this is the empirical formula of the compound. Now we are going to find the second question, which is molecular formula. Number 2, molecular formula. How do you find molecular formula? Before you can find molecular formula of a substance, you must first know the empirical formula. And we have found the empirical formula, which is CH2O. Now, put your empirical formula in a bracket, which is CH2O, close the bracket, attach a letter, you can use X or N. Generally, we use N. Now, your empirical formula multiplied by a constant N will be equal to the relative molecular mass of the compound. And if you can recall, the relative molecular mass of the compound was given to us in the question, which is given as 60. So my empirical formula, which is CH2O multiplied by N, is equal to 60. If you do this, all you need to find is the value of N. Now, CH2ON equals 60. I will change the elements into number. My carbon is 12 plus hydrogen is 1 multiplied by 2 plus oxygen is 16. All multiplied by N still equal to 60. My aim is to find the value of N. Now this is 1 times 2, which is 2. 12 plus 2 is 14, and 14 plus 16 will give us 30. N equals 60. Therefore, our N will be 60 divided by 30, and that is equal to 2. Now that we have our N to be 2, your molecular formula is this. The value of N, which is the constant, use it and multiply the empirical formula. Whatever you get is the molecular formula. Therefore, our molecular formula will be equal to, since our N is 2, we say 2 times this carbon is 1 here. 2 times 1 will give me C1, sorry, C2. Then 2 times 2 here will give me H4. 2 times oxygen is 1 here, 2 times 1 here will give me O2. So my molecular formula is C2H4O2. And that is the answer to the question. Assuming you were asked to find the composition of this compound, the composition means tell us the percentage of each of the elements present. Since I have carbon, hydrogen, and oxygen, the composition of the compound will be, it will mean find percentage of carbon, find percentage of hydrogen, find percentage of oxygen. That is the meaning of finding the composition. Find the percentage of each of the elements. If I want to find the percentage of carbon here, it will be mass of carbon, which is 0.96, over the total mass of the compound, which was given as 2.4, multiplied by 100 over 1. Whatever I get is the percentage. Composition of hydrogen will be mass of hydrogen, which is 0.16, all over the total mass of the compound, that is 2.4 times 100 over 1. And percentage of oxygen will be mass of oxygen, which is 1.28, divided by total mass, 2.4 times 100 over 1. If you punch out this, whatsoever you get will be the percentage of each of them, and that is the meaning of finding the composition. Thank you for watching this video. Please do not forget to like this video, share with your friends, and don't forget to subscribe to our channel.